Bismillahirrahmanirrahim. The first lecture was recorded and is available, and we discussed why the standard methodology for doing regression leads to wrong results. And I would like to go further and say that this regression methodology that we learned is nearly useless. Because basically it operates under assumptions. We all study faithfully the assumptions of the regression model, and we learn to memorize them and reproduce them. But we never check whether these assumptions are actually valid or not. And when you check these assumptions, you find that they don't hold. And if they don't hold, then the results are not valid. There are some cases in which regression results are valid, but they are quite rare, unusual. One of the things that I want to say is that in order to understand the world, data is useful, but it is never by itself sufficient. Now, unfortunately, in the West, there arose a illusion that the quantitative is the only thing which counts. So there is a Lord Kelvin's maxim that knowledge, if you know something, if you can measure something, then you can have knowledge of it. If you cannot measure it, then you don't have knowledge about it. So as a result, this came to be widely believed, and still widely believed. So as a result, quantitative methods became all important. Numbers will tell us everything, and things which are qualitative were disregarded. So psychologists started to measure the intensity of all of the intelligence. Actually, intelligence cannot be measured. Love, everything else. If you can't measure it, then you don't know it. So, in fact, most things that are important are non-measurable. And so, the attempt to quantify things actually led to big mistakes. Econometrics is also like this. Actually, the correct way to do econometrics is to look at data and to note anything that is unusual, and then to search for explanations in the real world about why this unusual thing is showing up in the data. But there was a general philosophical movement in the West in which they said that looking behind the data, looking behind the appearances to the reality is impossible, and this is not the job of science. This was actually a mistake. Even in science, this is a misunderstanding of science. But this came to be widely believed. So currently also, the situation is that the econometrics methodology that we are using is hopelessly flawed. It is impossible to get anything real understanding of the world from it. And so basically you can just throw all of these fancy econometrics textbooks in the garbage, and there will be no loss to the real world. In fact, there will be a lot of benefit, because people will not be able to deceive us. Joan Robinson is a famous economist, and she said that we learn economics not to understand how the world works, but to avoid being deceived by economists. So also, we need to learn econometrics not because it will teach us something about the data and the reality, but because we want to avoid being deceived by econometricians. Now, so that's one thing, that basically in econometrics, the results are obtained by piling assumption on top of assumption. Even the basic 5 assumptions that one uses in OLS are almost never fulfilled, which means that your results are almost never valid. And then when these 5 assumptions don't work, then you make much more complicated assumptions like arch and garch and egarch and so on, until you get the result you want, because the result you want is going to, there is going to be some set of assumptions which will give you the result that you want. So the results are, we are deceived into thinking results are coming from the data, when in fact everybody knows that to get a regression model you have assumptions plus data which gives the results, and actually it is not the data, it's the assumptions which drive the results, and by changing the assumptions we can change the results. So the idea that the data is somehow giving us the result is wrong. Data by itself cannot tell us anything. You have to impose some interpretation, some assumptions on top of the data to get some results. But the way that the Western philosophy of science evolved, they could not look at this because the assumptions were about the underlying hidden unknown structure, and so that part was not supposed to be important. So they keep saying that this is what the data is telling us, when data is telling us nothing. It's the assumption which is telling us. So that's some general philosophy. Now let's come back to some practical. I received a thesis which I caused a lot of bitterness by rejecting, because it was the final thesis and I said this is completely hopeless. So there was this student, he had studied the education levels of children, and he had a long list of variables. So for example, I want to ask what is the effect of mother's education. So he had a lot of variables, more than I can. Mother's education, father's education, family income, I don't remember. So he ran one regression for each. So my level of education equals alpha plus beta times mother's education. Now the beta coefficient is there and the R squared is there, and so then you say that okay, so if mother's education increases by 1 year, then the coefficient is 0.5, then the child's education will increase by half a year. And father's education is run again separately, and family income. So what is wrong with this thesis that was presented to me? With, there was the thesis, there was supervisor, committee, so it was a little bit difficult for me to say that this is not such a good idea. So what is your explain to me why there is a problem with this thesis? Yes. Misspecification. Well, it seems like a simple one. Mother's education is obviously relevant to child, so you run the education. Similarly, family income obviously matters. So what do you mean by misspecification? Yes, this is true, that all variables should be in one model, not separately. But can you explain? Basically, one thing I want you to understand is that there is this mystique. I remember that when I learned econometrics, I thought this was magic. You have data and then you wave your magic stick on the data and it produces the result. You don't understand what's going on. So You feed the data into the package and wow, you got the numbers and you got big names like integration and Box-Lung statistic and Johansson and so on, and everybody is impressed. You are also impressed and you get the results. The thing is that anything that basically data analysis is very simple. If you can't understand and if you can't explain to the ordinary person what is going on, then you don't know it. There's nothing very complicated, but people have made this into a mystical, magical box, and this is precisely to be able to claim expertise and to deny people that, oh, I'm such a simple person, I can't understand these things. So then the foreign expert comes in and he uses these fancy techniques and we are unable to argue. So what I'm saying is that the explanation for this is not very complicated. It should be understood, and actually there is a little bit of depth that is required. I mean, why should we include all the equations? Why isn't it okay to run the? Can you explain clearly to somebody who doesn't know any econometrics that why a regression of child's education on mother's education, which yields the coefficient of alpha plus beta equals 1/2. So this equation tells us that if mother increases by 2 years, then the child will, on the average, have 1 more year of education. So what is wrong with this? Actually, at one level, it is not wrong, but
it is not possible because if a person is illiterate, then it's not a guarantee that the children will be meaningful.
That is a wrong objection. Yani, what the regression model says is that this is the mean effect. This is not the particular effect. It is not true that every child whose mother is let's suppose it's very simple model. Child's education equals 1/2 mother's education plus epsilon. So if mother's education is 12 years, child education will be 6 years, and so on. Doesn't mean that every mother who is matriculate, her child will be 5. What does it mean, the regression model? This is the average effect, yes. If you take all of the mothers who have matric education and you take the average education of all of their children, this will be 5. But some of them will be 0, some of them will be university educated, and so on. So this is not the answer, wrong objection. What is the objection to this? Why can't we use these every variable we run the regression, we find the effect. We find father's education effect, that's, suppose it's 0.75, it means that the father's education is more impactful, and we find family income effect. Okay, let's just consider these 3 models to simplify. There's a whole list. Suppose that somebody comes in and says that I want to find out the effect of father's education. So here's my equation. It says education is. So I asked the registrar to hold the buses until the class finishes. So he says that the buses will leave at 4:30, so there's no problem. So the mothers. So this is the thesis. So we write a paper on this. There are 3 variables which are important in determining the child's education. It's mother's education. Basically, our finding shows that child's education is equal to 2 plus 0.5 mother's education, which means that on the average children have 2 years of education plus 1/2 of their mother's education. And similarly, we have another equation which says that the children's education is 5 plus 0.75 father's education. And similarly, we have something an equation which says something about how the family income can be used to predict. So then we run our interpretation, then we say, okay, this means that if we increase the education of women by 1 year, then the children's education will go up by half a year on the average. If we increase the father's education by 1 year, and similarly, if we increase family incomes by so much, then so much education will result. So what's the problem with this? बच्चा खुद ही ना पढ़ना चाहता हो तो how does that?
जितना भी उसकी मदद एजुकेशन इंक्रीज करते जाएं तो वो उसकी तो एजुकेशन नहीं इंक्रीज
we are asking that there is an analysis here. Now this analysis has some flaw in it. What is the flaw in this analysis?
Important variables
Huh?
Important variables are missing, like schooling, travel certification, qualitative certification, IQ level,
Yes.
So if we agree that these are the three variables which are affecting
Yes. Okay.
it would be better to run one model instead of these three models. Because by running one model, we are assuming that the effect of all other limited variables is captured by error term. So, जो आपने last time lecture में बोला था, wrong for proxy variables, जो wrong result आपके आ सकते हैं. So, single model में वो ज़्यादा बेहतर होगा इस केस में.
Okay, देखो, you have to learn to be more positive. This is on the right track. Let's try to focus on the problem. अगर बच्चे के लंबे बाल हैं, टीचर को वो नहीं पसंद आया, वो उसको निकाल देगा क्लास से, तो वो कैसे पढ़ेगा? This is totally ridiculous. It has nothing to do with what we are studying. We are studying regression models. Now, suppose that I say that, okay, let's study the consumption level of Pakistan, and I will study the impact of the income of India on Pakistan, and the income of China on Pakistan, and the income of Australia, and I run these regressions. What will happen? I will get, in every single case, I will get a very significant regression. Every single case, I will get a very significant regression, because why will I get a very significant regression? Both have increasing time trends, and when both variables have increasing time trends, then there is a very strong R squared. There is a reason for this. The reason is explained in my paper on methodological mistakes, which you should try to read. So then I will say, okay, here is my analysis. If India's income goes up by 1,000 rupees, Pakistan's consumption will go up by 20 rupees, and if China's consumption goes up by 1,000, then Pakistan's income will go up by 500, according to my regression results, and so on. So does this make any sense? It's absolutely nonsensical. It's complete garbage. But why? Why is there a problem with this? Okay, so then somebody says that, okay, I'm going to run the regression of income distribution on investment, and I take somebody else says, okay, I'm going to run the regression of religious variables on investment, because people who are religious tend to save more, and people who are secularly oriented, they spend more money. So there is a theory behind this. And somebody says that actually it's the intellectual property rights which determine investment, because if you have strong intellectual property rights, then people can protect the rights to investment. And so the theory you can always make up. I can make up a theory. Okay, India GNP affects Pakistani consumption. Of course it does, because the more Indians demand, we export our products to them by smuggling, and so our consumption goes down, and they're getting all the tomatoes that we are, and so on. So there's a theory. And similarly, China, we have a lot of export with, and so I mean, you can always make up theories to fit any. When the Phillips curve was run and the regression, and then the theory was made up afterwards. So no theory is not the right explanation. Yes, but here is a paper which says that it may be, but I'm running the regression separately, and I'm saying that Pakistan. Here is the effect of China. Like we discussed in the last lecture, that somebody wants to find out the effect of health on GNP, so he runs the health variable and he says, okay, here's the effect. Somebody wants to find out the intellectual properties and he runs that regression and he gets IPR effect. And somebody else, what was the third one? Was running FDI on GNP and he found that effect. So all three papers, there are three papers in PDR. One is telling us about what is the FDI and what is the impact of IPR and what's the impact of health on GDP growth. So similarly, here is this person, he is telling us here is the impact of China's GNP on Pakistan consumption, and here is the impact. One paper on that and one paper on Indian consumption and how it affects Pakistan GNP, and another one on Australian GNP. So what's wrong with this? I explained that the whole of the lecture of last time was on exactly this topic, but actually the thing is that it takes people a long time to understand these very simple things because they have been brainwashed very strongly. What does the encompassing principle have to say about this? What does the axiom of correct specification have to say about this? Yeah. They, this is just, this is true, but it is not the point. The point is that there is only one true regression model. All models different from the one true regression model are misspecified. When a model is misspecified, you cannot conclude anything from it. Let us suppose, to simplify life, that the one true model is the simple Keynesian linear model for Pakistan, and that is that C equals alpha plus beta y, where y is the GNP of Pakistan. This may be approximately true. Now, when you run consumption of Pakistan on GNP of India, then this is a misspecified equation. It is missing the key regressor, and therefore there is a bias. What is the bias? The bias is caused by the fact that you have included the wrong regressor and excluded the right regressor. So now what will the coefficient on India reflect? It will come because the GNP of India is correlated with the GNP of Pakistan, because both are increasing series. So the GNP of India will act as a proxy for the GNP of Pakistan, and the regression coefficient that you get does not reflect the effect of India on Pakistan. It reflects the effect of Pakistan on Pakistan, and the fact that Indian GNP is picking up the Pakistani effect. So there is only one true regression model, and so now what can you do? Well, according to standard theory. Now, if I put in the GNP of Pakistan, then it will be correct. Now, because the GNP, if I put in GNP of India, it is valid because it has a zero coefficient, so it is okay to put in the GNP of India and Pakistan and China and Australia. If you put in all four, there is no problem, because this is the model which encompasses the true model. Within this model, there is the three models that we discussed. The three models say that for example, consider the consumption of Pakistan on GNP of India. This is nested within the models because it says that coefficient of Pakistan GDP is 0, coefficient of China GDP and Australia GDP, these are all 0, and the coefficient of India is non-zero. So this hypothesis can now be tested. We take those three zeros and we use an F-test to see, and if things are working properly, which they might not be, there are reasons. I mean, we are just talking here now ABCs of regression, and I was going to cover more advanced topics, but it's clear that what I said last time was not understood. Please watch that lecture again and try to understand it. This is basically baby econometrics we are trying to teach here, and unfortunately nobody knows baby econometrics, and even not the student himself, the supervisor also doesn't know baby econometrics. So now, so if we test this, and if things are okay, and okay, for in baby econometrics, if we assume that things are okay, in that case, what will happen when we test the hypothesis that the Indian GNP is the sole explanatory variable for Pakistan consumption? How do we test this hypothesis? I just explained this. Can somebody repeat it to me so I can understand that it was understood?
So putting all other options equal to 0, all theta equal to 0.
Yeah. We put the three coefficients equal to 0. We have a F-test which will have T minus K and K degrees of freedom, where K is 3 and T is the sample size. And what will the result of this test be? Will it reject the null or will it accept the null? Come on. It will reject the null, yes. Will the F statistic number be big or will it be small? It will be big. The F statistic number will be big, the P value will be small, and what this means is that this event will be considered very unlikely under the null, because you have set to 0 the coefficient of Pakistan, and the coefficient of Pakistan is highly significant. So this hypothesis will be rejected. So the one India model will be rejected. And we will see, okay, so once the model is rejected, then it's meaningless. You cannot say that if we increase Indian GNP by 1,000, then Pakistan GNP will be affected by so and so because the coefficient is there, because that model is wrong. Model is wrong, so it doesn't have any meaning. Now we come back to this thesis, the effect of education, mother's education, father's education, income. These are the three variables. Let's suppose that he tested 50 variables, everything came out insignificant, these three variables comes out significant, and now he is telling us all of these policy conclusions that this is how we should affect the income, and this is what will happen with mother's education, and so on. So what is the problem with this?
The same one that the individual variables are being tested rather than the combined testing for exclusion and inclusion. that just like in the previous example, if people will individually select the series from China, from India, so the t-test will not reject the hypothesis. But the joint test has rejected the India model. So same is the case, we are just putting in and taking out the variables individually.
See, basically the axiom of correct specification says that the equation can be interpreted only if it is the true equation. So is it the true equation for education that child's education depends alpha plus beta times mother education? No, it is not. I mean, intuitively we can see that the income will be relevant variable, father's education will be relevant variable. So it is excluding two very important variables, which we know. So this model is misspecified. Because it's misspecified, it cannot be interpreted. Anything that you say is just nonsense because you don't have the true model. Similarly, for all of the others, suppose that the true model is that child's education depends on father's education and mother's education and income. This is the very easiest, simplest baby case. In that case, so the person has actually got the right three variables, but again, all of his interpretations are completely flawed, completely meaningless, completely useless. It might be, for example, this can easily happen, that family income is the only relevant variable. And if you run all three, you put all three, you will find that father's education, mother's education are insignificantly different from zero, and family income is right and relevant. So when you are saying that father's education matters, you are just making a mistake. And why? Because when you excluded the income, that was the important variable, then the father's income is acting as a proxy for this missing variable. And so it seems like it's relevant when it is not. It's just picking up the effect of income which is missing. Just exactly like when you put in Indian income and you don't have Pakistan income, then the Indian income picks up the effect of Pakistan. It acts as a proxy variable. So none of these single equation, in fact, you see, when you have two regression models, suppose we just, and he says, okay, father's income matters and this is the effect, and mother's income matters and this is the effect, then the thesis can be thrown in the garbage, because both of those variables, you are telling me they are both significant. If they are both significant, then both of those equations are wrong, because the father's education is missing one significant variable, mother, which according to you is significant, and mother's education is missing father's education, which is also according to you is significant. So both equations are, according to your own results, misspecified. In exactly the same way, if we get three papers from PDR, one is guy is telling us that the intellectual, this is actually the truth, this is one guy is telling us that the intellectual property rights matter, and he has a regression of growth on IPR, some variable, not just one. And then he is telling us the interpretation here is blah, 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 blah. And another person is telling us that FDI is what matters, and he is telling us the FDI growth. And then a third person is telling us about health. Okay, so all these papers are automatically wrong. It is not that maybe this and maybe that, and maybe people who are sick still go to school because they have determination. It is that all three models cannot be right. In fact, if the variables are significant, health is significant, IPR is significant, FDR is significant, then automatically all of these three variables are misspecified. It cannot be that they are correct, because if these three variables matter, then we need then each of these equations has very important missing variables, and the variable that you have is going to pick up the effects of the missing variables, and so it will have biased and uninterpretable coefficients. So the encompassing approach solves this baby problem in the sense that, okay, put in all of the variables that are relevant and then do the testing. So if I put in, so this is what encompassing does, okay, take all of the literature, take all of the regression models in the literature and make a model which is big enough to include all of them. Now this often runs into huge regression with lots of multicollinearity and many other problems. G.
Suppose on ग्रोथ के वेरिएबल को तमाम वेरिएबल को रिग्रेस करते हैं, तो अगर हम कहीं तो इट इज इम्पॉसिबल कि हम उसके तमाम रेलेवेंट वेरिएबल के डेटा कलेक्ट करें, अगर पॉसिबल है कि हम कलेक्ट कर लें सपोज, तो उसमें फिर मॉडल में जो है वो एरर टर्म का क्या रोल होगा? क्या मॉडल जो है डिटरमिनिस्टिक नेचर में भी हो जाएगा?
No, there is no chance of getting to a deterministic model, and basically what happens is that you have data on some variables and then you have missing variables and unobservables, so those are put into the error. Then a very important concept which is again very poorly understood and people keep making mistakes is that there are some variables which are dominant, strong determinants, and there are some variables which are weak determinants. You have to know the difference between these two because everything depends on this. So if you take something like let me say, okay, the effect of migration on yields. That's completely nonsensical. But somebody just yesterday he was coming in and he said something about how. Okay, so let me cover this. First of all, Yani, so yesterday somebody came in to ask me about. Now I've forgotten the variable that he wanted to study the effect of. Okay, let me make something up. The effect of rainfall on Karachi Stock Exchange market. Okay. So he said that, but I can't find any literature on this. so I said, yes, that makes a lot of sense because what if I were to study the effect of log depletion in the Amazon forest on Chinese consumption? So obviously when logs are being cut down, timber, and so some manufacture of sofa is taking place and some of that would be going to China, so there is some theory that, but it is also obvious that this is not going to be a big effect. it's very minor, almost imperceptible, maybe zero, very likely zero. So first of all, there are complete nonsense regressions, which people are saying, and nobody has ever done this before, so I can get a thesis out of this. So, like the effect of migration on crop yields in Azad Kashmir. Now, then there are things which are sensible, but not where the effect is not likely to be large. So for example, I don't know why at least 2 or 3 people in PIDE have done work on the effect of terrorism on FDI. Now, very possible that there is an effect, there is a logical relationship, but it's not going to be very strong, at least intuitively, for many reasons. FDIs. So, if you are picking up a big effect, then missing variables will introduce only small bias. So, if you pick up all of the major determinants of a variable which are in your data set, then your regression will be biased because of missing variables, but the bias will be small. So that's why, you can, of course, it's true that your model is misspecified, but you can calculate the extent of the bias, and basically if the missing variables have small effects, then the bias that is induced will be small. So that's how you can practically run the regression. Yes?
As per this approach, we have to put all variables in the model.
Yes.
So अगर let's say different जो models हैं हम उसमें identify करता हूँ 15 variables जो हैं वो मैं
Right.
So don't we face a degree of freedom problem here? Let's say manual data में पास 20 observation है 15 variable है उसमें कोई problem भी आ सकता है.
Yes, that is correct. For that, if you have a situation like that, where there is more variables than the amount of data points, that leads to a problem that you cannot estimate the full model. For this, Henry has actually devised a technique which is called impulse saturation. It is an advanced technique, and it allows you to assess the which of these combinations are good. So it allows you to drop the variables which don't matter and bring this into a place where normal estimation is possible. So that is not in this paper, THSY paper, but it is available. So basic idea of the encompassing is that there is only one true model. So if you are, so the current methodology says, okay, there are three true models. There's the impulse, the IPR model, intellectual property rights for growth, and this has these results, and you have a whole paper with all discussing all the effects of health on growth and the literature review and everything. And the model is wrong because he didn't do encompassing. And similarly, you have a IPR paper, and again, the model only looks at IPR and looks at previous literature and doesn't consider health, etc. So, encompassing is not only about making a big model. That's just one technique. You don't need necessarily to make a big model with all the variables. But what you do need to do is that, okay, I have my IPR model. Now I am going to show that health is not the right explanation. I have to prove that there are these three papers which have been submitted. I am going to prove that my IPR paper is the right paper and the other two are wrong. I have to prove that. So what I do is I take my IPR model and then I put in the health variables into my IPR model, and then I show that they are insignificant. And then I say that, look, the health guy is wrong because basically the health model's variables became significant because he was missing IPR. If he had put in IPR, and so the health variables are proxying for the IPR, and that's why they became significant. And once you put in both, then they disappear. So health model is wrong compared to mine. And then you take the other model, the FDI model, and actually most likely that would be stronger than the other two, but anyway, just for the sake of hypothesis. Okay, I put in the FDI variables and I put in my IPR, and then I show that the IPR variables are insignificant, the FDI variables are insignificant, and now I have a solid paper at least that my variables are significant, the others are not. But this doesn't quite conform to the encompassing methodology because there's a subtle trick now. Suppose that we go back. The idea that I'm trying to convey is that can we believe that what this guy is saying, he did this test, he put the IPR and the health, and he found that IPR is significant, health is not. He put in the IPR and the FDI, and he found IPR is significant and health is FDI is not. So he concludes that FDI is the significant determinant and the other two are not. Is this a valid conclusion in baby econometrics? No, why not?
Because we need a bigger model, more general model, instead of doing one by one.
No, but, why? What might happen? What might be the truth that would be missed in this analysis? Now, this is just the way that multivariate analysis works. I can show how it works. This really requires making some diagrams, but basically, it can happen that two variables are complements of each other in regression analysis. That is, if you put in both, then they are strongly significant. If you put in either one separately, they are insignificant because they support each other. They are each form one half of the answer, and individually neither of them is explanatory, but together they are very strongly explanatory. So if we put in health, IPR, and FDI, it might be that health and FDI come out strongly significant and IPR comes out insignificant. The same is true in this education example. Suppose that on a one-by-one analysis of 50 variables, father's education, mother's education, and family income, these three variables come out as significant, and everything else is insignificant. This doesn't mean anything. It might be that three variables out there which we didn't consider because all of them were insignificant. If you put them together, they are strongly determinant and they are the only determinants. And once you put on those three unknown variables, x, y, z, then your father's income and your mother's family income and father's education, they all become insignificant. So one by one does not help us to find these because of the possibility. Two variables can be complements and they can also be substitutes. So if the two variables are complementary, one by one testing will not find out that this is the case. So that's why we need to consider all three variables together. That's what the encompassing says. You can't do it on a one by one basis. Unfortunately, as was pointed out, we have no options. Degrees of freedom problem arises quite often. So people are always doing this, that they are doing one by one testing. And basically what that means is that in the end we have only a guess. It might have worked. Maybe, the possibility that I am mentioning, that FDI and health are strongly complementary, doesn't seem likely. So I can show that there are situations in which it occurs. I can create very natural examples where this kind of phenomena does take place. But more often than not, this will not be the case. So you will be able to conclude. But the thing is that in practical situations, this doesn't happen. In practical situations, this does happen. In practical situations, what happens is that you are forced to do this. You can't you start with a big model, regardless of how. Even Henry, in the DHSY paper, when he finished the analysis, the model didn't forecast well, and eventually he added in some ad hoc variables, financial liberalization, and that allowed him, housing, health, equity, I think it was, I don't remember. He added one ad hoc variable at the end, and that allowed him to fix the forecast problem. Now, what is wrong with this? According to Henry's own methodology, he came up with he analyzed three models, he did the encompassing, he found the best model, and then he did the forecast test, and the model failed the forecast test. He scratched his head for several years, I think 2, 3, 4 years. How can I fix this model? Finally, he added some financial variables, and now the forecast was fixed. Now, what is wrong with this methodology, according to Henry himself? No. Exactly. You see, you start with a model with 50 variables and you reduce it down to, let's say, father's education, mother's education, and family income. And you do it encompassing wise. So you put in all the 50 variables from the beginning, and then you get rid of the simplest way, which doesn't usually happen, is that you do a null hypothesis test on 47 zeros. The 47 variables which are not family income and mother's education and father's education, they are all having zero coefficients. You do a F test with 47 constraints, and then if the F test does not reject the null hypothesis, then you drop all 47 variables and you're there at the final model in one step. Normally it doesn't work like that. Normally in Henry methodology you have to go in several stages. You drop a few variables at a time and then you keep on doing until. So there's a process of simplification. And in fact this process is very tricky. It doesn't always work in the same way. But anyway, those are complications. In fact, there is a program for autometrics. There is a program called Autometrics, which is designed to do this. So you put in all of the variables and it automatically does the Henry methodology and does simplification after one, and it actually produces nice output that, okay, here's the first step and we found that these 3 variables were insignificant, then we dropped it, then we did the second regression, and then the second regression, this and this happened, and then we did this. And so it goes through a sequence of steps and finally produces, okay, this is your final model, which is the best simplified model that we get. Now, so I started with 50 variables. I tested 47 of them for significance. I found that they were all jointly insignificant. I dropped them all. I came up with the model, and this model doesn't forecast well. So then I think, and I say, oh, I omitted one very important variable that is not in my original 50, and this variable is, let's say, exports. Just for. So now I put in exports, and wonderful, the model starts forecasting correctly. I am done. Okay, my child's education depends on mother's education, father's education, income, and exports. And now my model fits well, forecasts well, everything is fine. No, because I didn't follow the encompassing methodology. Suppose I start now with all 50 variables and I add the export variable. Now what can easily happen, and does, in fact, it did happen in the Henry model, this exports is complementary to another variable which got dropped in the 47. So when this variable did not have its partner, it didn't show any life. It was dropped. But now when you put in the partner, this exports with this other variable, they become very strong and they explain everything, and family income and father's education, they all disappear. So this can happen. That's why it's dangerous to do this non-Henry methodology, to add a variable in the end in an ad hoc way. But usually doesn't happen, and basically life is like this, that we don't have the option to do everything all the time, so we proceed in an ad hoc way, but we must understand why this is risky. This is the problem. The people don't understand what's wrong with this. Yes? Exactly. दोबारा से करना होगा. Exactly. That is how it must be done. Right. Yes. Yes, that's right. That is not baby advances. That's now, when you talk about causality, you are getting into adult econometrics. Very difficult. Because it is not mentioned. It's a secret, you see. It's not mentioned in any of these econometrics textbooks. It's X-rated. So, yes.
सर अगर हम वेरिएबल इंक्लूड करते हैं बाद में मतलब में वो प्रॉब्लम हो जाता है कन्वर्जेंस
क्या मतलब मैं नहीं समझा
दैट्स व्हाट हम वेरिएबल मल्टीवेरिएट इक्वेशन तो उसमें वेरिएबल बढ़ाते हैं तो उसमें कन्वर्जेंस प्रॉब्लम हो जाती है.
Basically, if the number of regressors is bigger than the number of variables, then you don't get convergence problem. You can't invert the X transpose X inverse matrix. And this question was already asked, and I said that there is a special methodology called the impulse saturation methodology, which is used to decide which variables are significant when you have too many variables. Now, the next problem, just a brief hint at the causality issue that was mentioned by Faryal, that suppose that yes, okay, so let's think about it again in the context of child education, father education, mother education, and family income. Now, one has to distinguish. This is now we're starting to get into teenage econometrics. You have to distinguish between a correlation and causation, between observational relationship and between causal relationship. So when I run a regression of child education and mother education, and it gives me the result that child education is equal to 5 plus 0.5 times mother education, this does have a meaning. It doesn't. What is wrong is to use this as a causal relationship, to say that if we increase mother education, then the child. This just shows the regression is called a descriptive. It describes the picture that on the average, in this population, if you look at the mother's education, and if you look at the child's education, the child education is on the average 5 plus half times mother education. This is an observation. This is called a picture of the data. This doesn't mean anything. You see, the very serious problem with econometrics, as you have been taught, is that you have not been taught that there is a picture and then there is a reality. And these two things are different, and the reality is what matters and the picture is what doesn't matter. What you have been taught is that the reality is the same as the picture, and if the picture is good, then the reality is good. There is no such thing as a separate reality. This is the most serious problem and confusion. Causality is all about reality. It can never be captured in numbers. And that's why it's never mentioned in econometrics textbooks, except for Granger causality, which is a fraud. So, now, the regression is valid as a description. It is not valid as a causal relationship. So if we run a consumption function, C equals alpha plus beta y, this is valid as a causal relationship. If you run y equals a plus b times c, this will be an equally strong relation, because the regression and correlation are symmetric relationships. If x is correlated with y, y is correlated with x. So similarly, regression is also symmetric. If C has a very strong relationship to y, then y also has a very strong relationship with C. The R squared will be exactly the same, number to number, dot to dot. So, but one relationship is a causal relationship and the other one is not. If you take the consumption function and you say, okay, if we pump up the GDP by 100, and the NPC is 75, then the consumption will go up with 75, you'll be right. But if you say, okay, let us induce the consumers to, let's feed them some extra food every year, and so the consumption will double, and so the GDP should go to a much higher level, that will not be true, because there is no causal relationship. There is causal relation in one direction and not in the other direction. Here I am utilizing theory too, because, and of course this is this is also because Y is the dominant determinant. It is not a weak determinant of of consumption. It is the strong determinant. So we can say things like that, even though there are many missing variables in this function, even though maybe the interest rate is missing, maybe expectations about future incomes are missing, and many other missing variables which might be significant. In the error correction models, we learned that there are other significant missing variables. But even then, even when there are missing significant variables, if there is a very strong variable, you can get roughly the right answers. But if you go to weak variables, even when they are significant, then you have to have good specification in order to be able to get results. So, coming back to the causality, even if we run through the encompassing analysis and we put in all the 50 variables and we bring the equation down to child's education equals father's education, mother's education, and family income, this does not tell us about the causal structure of the model. And causal structure is everything. This is very important to understand. That if you want to know, if you want to learn something from econometrics, you have to know the causal structure. Yes, Umar.
If we follow encompassing approach,
Yes.
does that mean that Axiom of correct specification has been satisfied?
No, not it is the best you can do to come as close as possible. You can never know, just like all scientific theory, you can never say that it is true. Given a hypothesis, you can never prove that it is true. You can never get to a model and say that I know that this is the true model. But you can say that I have tested it in all possible ways that I could think of, and it has survived all the tests, so it is the currently best available model.
So, given our data and given our understanding how
Yes.
generate that is,
Yes.
so we are approaching towards Axiom of correct specification.
This is the best you can do, yes.
So, if that is the case, then does not that take care of causality?
No, it doesn't. Causality is at a different level. This is at the deep level. We're talking about the surface level. So, this is the best relationship among these variables, but the relationship, the causal structure of the relationship is unknown. For example, let us suppose that the driver, okay, I'm going to describe a causal chain, that okay, people get educated, the education determines perfectly their income. So whoever has matric, he is earning 5,000, whoever has inter, he is earning 10,000, and so on. This is just to fix the causality so we can understand the argument. So education is the cause of income, and also let us suppose that a person who is educated, he selects his wife according to his education level. So if he is a matric, he will select 9th pass and so on, just one level below. Therefore, the causal relationship is that father's education, it drives mother's education, it drives family income, and this determines child education. Now the equation is not going to tell you this. The equation will show, can show anything actually. It's very strange, but the equation might show that the mother's education is the most important, it will have high significant coefficient, or it might show that the family income is very important, when in fact the causal structure is that the father's education is the only thing which matters. And if you do the significance test, according to the causal relationship, father's thing is the only thing which matters. The other things are not important. But the regression will not reveal this. The regression might show that both family income and mother's income is significant. So the regression actually mislead you on the causal relationship. So now, what can be done? Is there a trick? There are no tricks. This is the really strange thing. There are no tricks by numerical tricks which will reveal the causal structure. So how will you know the structure? You have to go out in the world. You have to spend shoe leather. This is what Friedman said. That in order to discover causal structures, you have to spend shoe leather. That is, you have to go out in the real world and look. Let me give you a real example from the Lahore survey of rural education. So now, on the surface, it appeared that the data analysis, simple data analysis, shows that the female children of equal ability are receiving less education than male children. This is what data showed that. So they investigate why is this. The obvious implication would be that parents are in favor of educating sons and not educating daughters. But when they did the data analysis, they found this was not true. They found that if the parents are gender neutral, very surprising finding. If they of course there is a limitation. The parents do have to choose because in rural areas people are poor. If you're going to put only one child, the parents do choose the best child. Yani whoever is most brightest, they take their best shot. So they tested it. They found that okay, if it's they think that the girl is bright, they will send the girl to school. If they think that the son is bright, they will send the son to school. They are not gender biased in that way, which is surprising finding. But anyway, that is what they found. Then they also found they thought that there is one possibility that the parents are biased. They cannot pick out who is the best child. This is another hypothesis. They tested it. They did a correlation between the teacher's evaluations and the parents' evaluation. They asked the parent to evaluate which of the children do you think is the brightest, and then they checked the records in the school and they found a very good match. So it is not that the parents, and this is also again surprising finding because the parents were often uneducated. So how can they tell who is bright and who is not, who knows math? But they can. The parents have enough understanding that they can say that this child is bright and this is not so bright. So now these three findings, they are a contradiction. Yani parents are not showing gender preference. Parents can identify who is the brightest, but the girls are not getting the same education as the boys. Why? So shoe leather. They went out and they walked around in the fields and they found out that if there's a school that is very far, then the son will be sent, but the daughter will not be sent. So the parents, the girl's education depends on making sure that there is a school nearby. If the school is far away, then the parents will send. So this is those are the education. So the data will not reveal anything about this. And if you do any kind of regression, whether you do factor analysis or whether you do however you torture the data, you will not get this out of it. You will have to go into the field. Yes.
I want to go.
This doesn't relate to the issue that I am discussing, in the sense that I am saying that the causal relationships cannot be discovered in the data. You have to go into the field and learn, talk to the people, find out why this is happening, and then you can. So anyway, what I am saying is that the causal structure, suppose we want to find that okay, the father education is in my hypothetical model is the central causal variable, then it will not be the case that a regression of child education and father education will produce the highest R squared, pointing out that this is the real variable, and the other regressions will be coefficient. The data will not give you the clue to the causal structure. So how can you find out the causal structure? You have to go into the field and find out what, you go and talk to the people, why are, exactly as in the Lahore rural education study, go and talk, who do you select for education, why do you send them to school, what are your problems, and so on. You might discover something which, a variable which is not mentioned in your data set, which is crucial determinant. So the causal structure is not revealed by the data. There are some tricks, it is not totally impossible. There are some clues that are available from the data. Basically, if two variables move together, then there are four possibilities. Either this is a spurious correlation, it is by accident. So, for example, there was something which was called the Harvard Barometer. In the Harvard Barometer, they looked at a number of leading indicators to predict business cycles. These were the variables which were always moving first, and then if the variable moves up, like construction starts, then the economy would improve in the next quarter. So they used this barometer to say, okay, and for a while it worked well, and then it started making a lot of mistakes, and so they dropped it from use. Similarly, there is this small state, I think it's called New Hampshire, which has a very small population, but for about 50 years, whoever won in the New Hampshire primary, he would win the US presidential election. So this was just correlation. It was not a causal relation, but people became very superstitious. They said they would put a lot of effort into winning the New Hampshire primary. Now, very interestingly, when you come to human affairs, there is a self-fulfilling prophecy element. If people think that this candidate is going to win, this will have an effect, even though they might not be. So, an accidental correlation can turn into real. And this is not just a hypothetical thing. Actually, studies show of monetary policy that the confidence that the people have in the ability of the monetary authority to control inflation is extremely important. And if you are in a country in hyperinflation is running and you want to get it under control, then gaining the trust of the people is all important. You can do a lot of things, and if the people think that the monetary authority is incompetent and they will not be able to control, then you will not be, because the expectations determine. Because you see what's happening is, I am hiring a person and now I am going to give him wages according to what I think. Okay, I'm setting his wage level for the next year. Okay, your salary will be so and so. Now if the inflation is such that the income will double, that the price level will double, then I will make sure that the wage is also corresponded to the idea that the wage next year, the real value of the wage will be half. So I will set the wage at a level, even though it will be constant throughout the year, that earlier it will be higher than what he needs and later it will be less. Now suppose that everybody thinks that inflation is going to happen. Then people are setting prices also, and they are also following this policy. They can't go in and change prices every day, so they set the price accordingly. So prices are being set, wages are being set, and this is all depending on what I think. So if I trust the monetary authorities that they will get inflation under control, then I will set these differently. But the wages and the prices setting is exactly what inflation is. So the confidence level makes a big difference. And that's why, in monetary theory very soon, expectations, we were also doing here the inflation expectation survey. Why? Because it was discovered that these variables are very important. So what we were talking about was causality. So now the causality here, especially in human affairs, becomes extremely complicated, because it might be that there is no causal relationship between New Hampshire primary and the presidential election. But if everybody believes there is, then there will become. This is called the phenomena of sunspot equilibria. Especially this occurs in monetary theory. That if everybody believes sunspot is an external signal which has nothing to do with reality. So suppose everybody believes that tomorrow I will be in the monetary policy committee and will make the decision. Suppose, and actually things work like that. What is the impact of the decision? What is the decision? The decision itself sets the overnight money market rates. So we are going to decide how much, when the banks borrow make a short-term borrowing from the central bank, what is the rate of interest they will pay? Suppose it's 5%. Okay, so suppose we change the 5% to 4%. What will the impact of this be on the economy? When you study this, you find that there is no direct channels. This doesn't have a big impact on anything that you can imagine. But the biggest impact is on the expectations. When the monetary authority cuts the interest rate, then people take it as a signal that the monetary policy is going to be loose, money is going to be available, so there is some inflation that is likely to be generated, and also there are other variables which, when basically it's taken as a signal. And so the signal effect is much stronger than the so-called real effect, which works through the mechanical channels. So the monetary policy works through the expectation channel. So how do we know this? Well, basically one has to do a lot of detailed analysis of the world, real world. It cannot be done just by crunching numbers and so you have to. So basically historical and qualitative analysis are essential. So if you read John Williamson, Failure of International Monetary Reform, so he discusses all of the players and what they were doing and what they were trying to do, why did Bretton Woods fail, and who made that. So all of these things matter. You see, what you have been trained to believe is that only the numbers matter and you don't have to learn the history. But the truth is that history is all important. From the history you will learn the factors which made a difference, and actually history is also not something which is out there so you can just go and learn the facts and learn history. Actually history is also a story that is being told on the basis of the same set of facts. And if you read my articles, I am showing how some people are constructing one story, but other people are using the same facts to construct other stories. And these stories are telling us what the causes are. I mean, according to one story, the cause of the global financial crisis is X. According to another story, the cause is Y. All of the stories, which are good stories, take into account all of the facts. And ultimately then, it becomes a question of your intuition and decision. But one thing to understand is that without knowing this background fact, you cannot learn any econometrics. You cannot do any econometrics correctly, because the real thing which drives the world is the causal structure. If you know the causal structure, you can do econometrics correctly. The econometrics will not reveal the causal structure. If you see, I've been using the consumption function. Now, this is because intuitively we know that income determines consumption, because I know from myself, I have income, then I think about that, how much money do I have, in order to decide what I am going to spend, and I assume that other people are also like this. So it makes a lot of intuitive sense that the GNP is the driver of the national income, is driver of consumption. Equally, we can intuitively think that my consumption is not the main determinant of GNP. GNP is being determined, income is determined by jobs and by productivity and so on. So how much I decide to buy will not cause GNP in any important way. So the correct equation is C equals alpha plus beta Y, and not Y equals alpha plus beta C. But to learn this, it requires knowledge about the real world. If I just have two time series of numbers, I cannot decide which is which. Without having knowledge about the real world, I cannot. And this is true for all of econometrics. And that's why people not understanding this take these idiotic things like, okay, I'll take the rainfall in Brazil and run a regression. What is the impact of rainfall in Brazil on Chinese consumption? And just yesterday they said somebody came in with such a nonsense regression, and they come up routinely in thesis. People are always looking for something new to do, so they say, oh, here is a variable and here is another variable, and nobody has studied the relation between these. Well, there is a good reason, there is no relation between them. But the thing is that if you run a regression, you will find a relation. Why? Because the variable will proxy for the true variable which is missing. Okay, so I didn't get to the issues that I was, because basically I'm rehashing last time's lecture, but no, we did cover causality issues. So I think I'll stop here, and next time we will discuss more on exploratory data analysis. Okay, thank you.